So who can tell me what they found when they substituted 0 in to the function? Yeah. It's 0. So it makes sense. At 0 time, right here, the frog just chilling. Okay? Now, h of 0.8, what'd you get? 0. Which means I have another x-intercept. So there's two options here. Either this frog never jumped, or it jumped and landed, right? So how could you, let's say, obviously it jumped because it says it jumped, but even if you didn't, you could just test any point between 0 and 0.8 and see any of them. But let's talk about 0.4. How long did it take to get to the max? 0.4 seconds, right? And we know that the axis of symmetry happens right in the middle. Now, it doesn't ask this. I'm going to write vertex, 0.4. But I can find how high this frog jumps. How can I figure out how high he jumps? Brennan?
Substitute 0.4.
Yeah, I need h of 0.4, right?
Yeah.
At 0.4 seconds, he'll be the highest.
Yeah.
Uh-oh. Ran out of room. Minus 75 times 0.4 squared. And I got 12 inches.
Ooh.
So 0.412 is our vertex.
How do you go up 12 inches and over in 0.8 seconds?
Pretty quick, I would imagine. Some might say this frog has hops. Other places we can see these things. Up in here, right, what's my y-intercept? It's the constant. Yeah, it's 0. It's missing, right? So that's another pointing to our 0, 0 there. Then we could factor out a t. Do you guys see that? You could put factored form by factoring out a t. 60 minus 75t. And here's what a connection I want to make with this. This t says intercept what? 0, 0. To get the other intercept, I could set this binomial equal to 0. And if we do the 2 steps of algebra, guess what t equals?
0.8.
0.8. If I were to subtract 60 and divide by negative 75, I get 0.8. We didn't need to be given these. We could have actually gone factored form and found those intercepts. It works out. Kind of cool, huh? Just more things. More things we're able to do every day. So what we're going to focus on today is matching up. We're going to continue matching up graphs. We're not actually doing the graphing. This is given up here just as a reminder. Do you guys remember that original cannonball problem? Where the cannonball was shot from 10 feet at a velocity of 406 feet per second and gravity was pulling it down? We're going to transfer that knowledge to here where we're catapulting a pumpkin. All right? Anybody ever trebuchet a pumpkin? I've done it before. They used to put this place up in like a Greenville. Anyway, this is the function for catapulting this pumpkin. Your job is to identify what the different parts of the function mean. If we graph it, how would it look? Try to come up with a vertical and horizontal intercept. Do your best. You're going to need probably some guessing and checking because this is standard form. Can we factor this currently? Can we factor this standard form? You cannot factor this one currently. All right, so only do number 1. Only number 1 with your partner. Let's go. So let's talk about aspects of our function. Who can help me out with saying what the 2 is in our context of our situation?
That's the height when you launched at.
Y-intercept. Oh,
JP?
I think it's the height that the pumpkin or
Yeah, it's launched. It's our constant. It's our y-intercept, right? So that's where the pumpkin's getting sent from, 2 meters. Who can tell me about this negative 4.9 t squared? What is that? Okay, yeah, gravity. So gravity's going to be different. We got that negative 16 t squared once. That's kind of like a theoretical thing, but then every item, gravity's going to have a different effect on because we have atmosphere. So, yeah, that's it. How it's coming back down after the launch. And then it's missing it. It doesn't have it in here, but who can tell me what this 23.7 is? What's going on with that, Sean?
How fast it's going.
Yeah, the velocity in meters per second. Just like that cannon, right? That's how fast it's getting sent. If we graph it, Vinny, does it open up or open down?
it opens downward.
Okay.
Unless you shoot it into a pool.
It opens downward like this. So I always like drawing just like a mini graph, right? Here's that y-intercept, and it's opening down. What's the indicator that it's opening down on our function? Like, you wouldn't even need situation. I can tell you by looking at the function. What part of the function says it's opening down? Troy?
The minus 4.9.
Yeah, so remember back when we were messing with the coefficient of our quadratic, the positive ones opened up, the negative ones opened down, when we had like that x squared and the negative x squared. So even without context, we can look at our function right there and say opens down. Now the next thing it asks for, we already got the vertical intercept, right, 0, 2. The x-intercept's tricky with our skill set, okay, with our knowledge. So we're looking for what this would be. Where that happens, what is the height? No, the height.
What do you mean, the height when it's
Right here, what's the height?
0?
0. So really what I'm trying to find is a value for t that gives me 0, right? And guessing and checking is all we can do with our skill set since we can't get this in factored form.
Our skill set is
So
not good.
I guess and checked, and I got somewhere close to like 5, I believe. I'm going to double check that. Yeah. So when t is 5, when the time is 5, I get like -2, 0, -2, or -2, 0. So that means at 5, it's slightly below. But I'm going to go with 5-ish, okay? So when I plug in 5 for time, I get a -2. 5's close. With our skill set, we're just going to be able to get close. Now, the next thing it's asking for is when will it be its highest? Well, the vertex would be close to what? It'd be close to 2.5, right? We know it wouldn't be exactly 2.5 because the other 0 would be like left of the y-axis. Yeah, but we're gonna rock a 2.5 just to see what we get. So if I put a 2.5 into my function, which is 2 plus 23.7 times 2.5 minus 4.9 times 2.5 squared, I get 30.625 meters. Man, that decimal gave me a hard time, didn't it? Let's try that again. 30.625 meters, so almost 100 feet up. This is a pretty good catapult, huh? Yeah. And so this would be our vertex. Again, just big reminders, vertex halfway between the two zeros. The axis of symmetry runs through it. If I know my x, how do I get my y?
Test it.
Plug it in and pump it out. Yeah, test it. Then the function. There's our intercepts. Now, what do they mean? How many x-intercepts in our situation?
1.
Ooh, I'm hearing 2 and I'm hearing 1.
No, 1.
Well, technically,
There's a theoretical. Yeah, so this is good. This is why we talk about it. In terms of our function, 2 zeros. But in context, since it's starting from 2 feet, it's only hitting the ground once. Okay? So technically, we have 1 0 in context. Zip? Next thing we got to do. We're talking 2 baseball players. And they're hitting. They're hitting a ball. Player A is the graph. Player B is the function. And you need to take what you know about graphs and functions and answer which player's baseball stayed in the air longer, which players went higher, and how can you tell where the ball was hit, from what height. Right? If it's golf, maybe we're hitting off the deck. But when you're hitting this baseball, it's not starting on the ground, right? So this first one was just a looker. Who can tell me how they know which one's in the air longer? So which one is in the air longer, and how do you know? Sophia? Which one's in the air longer? You got B in the air longer? Okay, how long was player B in the air? 4 seconds. Okay, so how long was player A in the air? So who is in the air longer? Okay, there we go. That was good. So player A, 5 is greater than 4. So we got that 4 right here. Everybody good with that 4? Okay. The other intercept, some people back here were looking for it even though we didn't need it. I like that because it'll help us find the height. I'm also going to draw a little, it says don't draw, but I'm going to draw a little player B. Here's that 4 0 right there. Okay. Now, there is another 0 in the function. that 0 happens when I can get this to equal 0, correct? So there's a couple ways to do it. You can sit here and say, I need to make this a 1 to get a 1 minus 1. Or we can do 2 steps of solving an equation to get my 1/16, negative 1/16. So that's my other, like, theoretical right here, back in time, x-intercept. So when I'm talking about how high does it go, which one goes higher, whatever, that 1/16 probably isn't going to play into the axis of symmetry enough to mess. If we get an answer that's close, then maybe we consider it. But our axis of symmetry should be pretty close to what for my x value? For player B. Player A is easy. It's right there, right? It's 2.5, 110, let's say. But for player B, what is that close to? The axis of symmetry is close to what? 2, yeah, halfway between 0 and 4. Okay? So I throw 2 up into my function there. Negative 16 times 2 is negative 32, minus 1 is negative 33, times negative 2. It goes up 66. So which one goes higher, A or B? A. Well, A's just killing it compared to player B. Sweet. And then last, how can we tell the height?
66.
I put in the time for the axis of symmetry, correct?
Yep.
I substituted this 2 right up in here. Oh, wait. That's the height for the vertex. This one's asking for height. It was hit. So let's go back down there. So if this is my function, this is fractured form, correct? What's the best way to find the y-intercept? Not from factored form, I'll tell you that. It's not popping on factored form.
The constant.
I need the constant, so how am I going to get a constant out of this? Distribute, yeah, simplify, distribute. So if I put it in standard form, I get negative 16t squared. 16 times 4, 64, plus 63t, plus 4. So where's this player hitting it from? 4 feet? And we know because constant. I don't know. 4 feet. Yeah, 4 feet. That's a depends on how tall the person is, right? It's our y-intercept. Now, how many zeros are there in context?
Can we and JP together?
1 0, right? This other 0 is like a fake one. It's in theory, right? Back in time. In context, this ball only hits the ground once. It's getting hit, and then it's going to hit the ground when it gets to the ground.